Imagine you're floating in space. No gravity, no sound, just endless black stretched out in every direction. And then you see it, a point of absolute nothing. Not dark like a shadow, not dark like night. Dark like the universe itself forgot to put something there. You're still far away, safe, watching. But here's the thing nobody tells you. The moment you start falling toward a black hole, you can never know it. Because from where you're standing right now, you feel nothing. No pull, no warning, no alarm. And by the time you realize what's happening, you've already crossed the line you can never come back from. Let's back up. Most people picture a black hole like a cosmic vacuum cleaner, a giant hungry mouth, sucking everything in. Movies love this image. A ship gets too close, alarms blare, crew screams, ship crumbles. That version is wrong, not partially wrong, fundamentally, completely wrong. A black hole doesn't suck. It doesn't reach out and grab things. It does something far stranger, something that breaks the rules of everything you were taught about space and time. To understand what actually happens, you need to understand one thing first. A black hole is not an object. It's a wound in the fabric of space-time itself. Imagine space-time like a stretched rubber sheet. Put a bowling ball on it. The sheet curves. Now imagine something so dense, so impossibly heavy that it doesn't just curve the sheet. It punctures straight through. That puncture point? That's what we call the singularity. And around it, at a precise distance, the event horizon. This is the line, the point of no return. Not a wall, not a barrier you can see or feel. Just an invisible boundary where the laws of physics quietly give up. Here's where it gets strange, and stay with me, because this is where almost every explanation gets it wrong. If you were falling toward a black hole, someone watching you from far away would see something remarkable. As you approach the event horizon from their perspective, you slow down, and slow down, and slow down, until right at the horizon, you appear to stop completely, frozen, like a photograph of yourself, hanging at the edge of infinity. They would never see you cross, but you wouldn't notice a thing. No jolt, no flash, no dramatic crossing moment. From your perspective, you sail right through, and the universe continues on around you, looking almost normal. Almost. Here's what nobody talks about, the part that genuinely disturbed physicists when they first worked it out. Once you're inside the event horizon, the singularity is not in front of you. It's in your future. Think about that for a moment. In normal space, you can choose to move towards something or away from it. The singularity feels like a place, a location in space. But inside a black hole, space and time swap roles. The singularity becomes a moment in time rather than a point in space, which means avoiding it is like trying to avoid tomorrow. You can't dodge left, can't burn your engines and pull up, can't choose a different direction. Every path forward, no matter what you do, leads to the same moment, the end. Now, before you spiral into existential dread, let's talk about what the journey actually feels like. If this were a stellar mass black hole, the small ones born from dying stars, you'd experience something that scientists gave a darkly poetic name, spaghettification. The gravitational pull on your feet, closer to the singularity, would be so much stronger than the pull on your head, just a meter or two further away, that you'd be stretched vertically, thinned out like cosmic pasta. It would happen before you even cross the horizon. Violent, brutal, the molecules of your body torn apart at the seams. But here's the twist, and this is the part that almost feels like science fiction, except it isn't. If you fell into a supermassive black hole, the ones at the centers of galaxies billions of times heavier than our sun, the tidal forces at the event horizon would be gentle enough that you might not feel anything dramatic at all. You could cross the horizon of the largest black holes in the universe and not even realize it had happened. You'd just keep floating. The same stars above, the same darkness around you, but behind you, invisible, permanent, absolute. The door would be closed. Now, here's where it gets really strange, because so far this has been the physicist's account, what the math says, what general relativity predicts. But there's a problem so serious that Stephen Hawking spent 3 decades arguing about it and eventually admitted he was wrong. It's called the black hole information paradox. Here's the idea. Everything that falls falls into a black hole, you, a rock, a star, a beam of light, carries information. The specific arrangement of its atoms, its history, the fact that it existed. Physics has a rule, one of its deepest rules, that information is never truly destroyed. It transforms, it scrambles, but it survives. A black hole, however, seemed to break this rule completely. Hawking proved in 1974 that black holes slowly evaporate. Over billions, trillions of years, they radiate energy and shrink until one day they vanish entirely. And when they vanish, what happens to everything that fell in? The information, the memory of every particle, every atom, every version of everything that ever crossed that horizon. Gone? This is the paradox. And for 50 years, the best minds in physics couldn't agree on the answer. Some said the information escapes, encoded in the radiation Hawking discovered, just scrambled beyond recognition. Some said it's stored on the event horizon itself, like a cosmic hard drive. Some said it leaks out at the very end, when the black hole's final moments create a burst of complexity we don't yet have the math to describe. And some, the most radical, suggested that perhaps everything that ever fell in gets copied, that the original falls toward the singularity, and a perfect copy, encoded in radiation, escapes back into the universe. Which means, in some interpretations of quantum physics, you don't die when you fall in. A version of you survives, scattered across the radiation, encoded in light, dispersed across the universe like whispers of someone who once existed. So, what really happens when you fall into a black hole? It depends on who's watching. From the outside, you freeze at the edge of forever. A ghost, a photograph, someone who never quite disappeared. From the inside, you cross a line you can't feel and inherit a future that leads to only one place. From the universe's perspective, the question might not even be settled yet. But here's what I think that matters most. Black holes don't just swallow, they reveal. Every time we've tried to understand what happens inside one, we've learned something deeper about time, about space, about the nature of information itself, about what existence even means. The universe is not giving us horror stories when it shows us black holes. It's giving us the hardest questions it knows how to ask. And maybe that's the point. Every civilization that ever looked up and wondered, every scientist who ever stayed up at night arguing about what happens when the laws of physics break, they were all asking the same question. What is real? What survives? What matters? A black hole is the universe's most brutal attempt at an answer. Now, I left something out, intentionally. There's a theory, emerging from the latest research in quantum gravity, that suggests the singularity at the center of a black hole might not actually be what we think it is. That instead of infinite density, there might be something on the other side, something that looks a lot like a beginning. If you want to know what that theory is, cite and why some physicists think black holes might be the birth of new universes, that's the next video. And if this video changed the way you picture black holes, drop a comment below. I want to know, what surprises you most about what actually happens? Because honestly, the more I learn about black holes, the more I think the universe is not trying to scare us. It's trying to show us how extraordinary existence actually is.